Hey everyone, welcome. Today, we're putting on our detective hats to investigate one of the deepest, most mind-bending mysteries in all of physics, the case of the missing time. It's a real head-scratcher that starts with our most advanced theories and ends up questioning the very fabric of our reality. So let's dive in and see what clues we can find. All right, let's just jump right into the deep end with the one question that really keeps physicists up at night. What if our most fundamental sense of reality, that feeling of time passing, of one moment flowing into the next, what if all of that is nothing more than a profound illusion? Okay, so think about it like this. Over here on the left, that's us. That's our gut feeling about time. It feels like a river, right? It's always flowing, carrying us from a past that's done and gone through this moment right now and into a future that isn't written yet. But then you look at what our best, most fundamental physics tells us, and it's a completely different story. It points to this static, frozen reality, sometimes called the block universe, where your past, your present, and your future all exist at the same time. They're all equally real. And the clash between these two views, well, that's the heart of our mystery. So how on earth did we get to this bizarre idea? Well, to figure that out, we've got to go right to the edge of what we know in physics. We're talking about the search for a theory of quantum gravity, a single, unified theory, a theory of everything that can describe the entire universe in one go. And this is our crime scene. The whole problem kicks off when physicists try to unite the two giant pillars of modern physics. You've got Einstein's general relativity on one side. That's the stuff that describes gravity, black holes, the whole universe on a massive scale. And on the other, you have quantum mechanics, the incredibly weird but accurate rules for the world of atoms and particles. The trouble is, when you try and smash them together, poof, something vital just vanishes. And that vanishing act, it leads us directly to the smoking gun. It's a single equation that's supposed to be the master key to the whole universe, but it holds a clue so baffling, it threatens to unravel everything we thought we knew about time. We're talking about the Wheeler-DeWitt Equation. You can kind of think of it as the ultimate version of the famous Schrödinger equation from quantum mechanics. Basically, its job is to give us the wave function of the universe, a complete quantum recipe for everything, all at once. And here it is. Now, what's so wild about this isn't what you see, it's what you don't see. See, in pretty much any other physics equation that describes change, you'll find a little variable, t, for time. It tells you how things evolve. But look closely at the Wheeler-DeWitt equation. It's just not there. Gone. The equation basically says the state of the universe doesn't change. It doesn't evolve in time. So what does that mean? It means this equation is describing a universe that's completely static. It's like having an infinitely detailed photograph that contains the entire history of the cosmos, the Big Bang, the dinosaurs, you listening to this right now, everything. But there's no play button. The whole thing is just frozen. So the billion-dollar question is, how do we get from that to the moving, changing world we all experience? Okay, so if the universe is frozen, this leads us to our first major suspect for where our experience of time comes from. It's a truly mind-bending idea called the Page-Wooters mechanism, and it suggests time isn't fundamental at all. Instead, it emerges from one of the weirdest parts of quantum mechanics, entanglement. That's that spooky action at a distance Einstein talked about, where two particles can be linked across the universe. So here's the wild idea. Imagine you could split our static frozen universe into two parts that are quantum entangled. Now let's just decide that one of these parts is our clock. The other part is the system. That's the rest of the universe we're observing. Here's the trick. Because they're entangled, as the state of the clock changes, the state of the system also changes in perfect sync. So for anyone inside that system, it would look and feel exactly as if their world was moving forward through time measured by that internal clock. Time in this view isn't a real fundamental thing. It's just a relationship, an illusion born from entanglement. All right, our next group of suspects, they take this whole it's all about relationships idea and really run with it. These theories say that time doesn't have any absolute, independent existence at all. It only ever shows up in the way things interact with each other. You've got the physicist Carlo Rovelli, for instance. He basically says asking what time is it for the whole universe is just the wrong question to ask. It's meaningless. You can only ask how one thing, like a planet, changes in relation to another thing, like a star. Then there's a different but related idea from loop quantum cosmology. This one suggests that time isn't the smooth, continuous river we imagine it to be. Instead, it emerges in tiny, indivisible quantum ticks. like the individual frames of a movie, that when played together create the illusion of smooth motion. Okay. So we've been digging through some pretty heavy physics. But what does any of this actually mean for you and me? I mean, what are the stakes here? Well, the philosophical implications of a timeless universe are absolutely enormous. They challenge our deepest assumptions about what reality even is. Well, it basically throws us into a huge philosophical debate between two big ideas. On one side, you have presentism. That's our everyday, intuitive view. Only this present moment is real. The past is gone, the future hasn't happened. The problem? That idea is flatly contradicted by the Wheeler-DeWitt Equation. On the other side, you've got eternalism, that block universe idea we talked about. It says the past, present, and future are all equally real, and our feeling that time is flowing is just a subjective illusion. And weirdly enough, the physics we've looked at seems to point strongly in this direction.
And if that's true, I mean, the implications are just staggering. Cause and effect, that might not be a process that moves forward, but just a fixed pattern within the static block. And what about free will? Our sense of making choices in the moment would have to be completely rethought. After all, if your future actions already exist as part of this block, were they ever really your choice to begin with? And maybe the most mind-bending part, it means the entire history and future of the universe simply is a single, unchanging, four-dimensional object.
Look, this is obviously a huge, complex mystery, and we've really just scratched the surface today. If this has got your gears turning and you want to dive even deeper, the sources for this explainer are fantastic. They're written by the actual physicists working on this stuff. Seriously, if you want to continue the investigation, check them out. So this all brings us right back to where we started, but with a question that's now way, way more personal. If the physics is on the right track, if the universe really is this static, timeless block, then your entire life, every moment you've lived and every moment you will live, already exists. It's not happening, it just is. So let me ask you this. Is your entire story already written? That's something to think about.